So the last section in the series is going to be um, transforming. This is a different kind of transforming a set of vectors in the standard basis. Here's will actually be constructing a matrix of the transformation using a transformation. But this is when we don't have when we don't have no or missing standard basis vectors. Standard basis vector transformations. Okay. All right. So let's say, for example, we have t. We're going to go from R3 to R2. Not R3 to R2, excuse me. Yes, R3 to R2. Okay, and what we know is t of 1, 0, 0 will go to 4, 5. T of 0, 1, 0 will go to negative 1, 1. And t of 2, 1, negative 3 will go to 7, negative 1. Okay. Now, what we notice is that we have one of the standard basis vectors, 1, 0, 0, a second one for 0, 1, 0. Okay, but what we lack is we need t of 0, 0, 1. So what we're going to do is we're going to use the property of linear transformations, the fact that we know that the matrix is a linear transformation and that this is a linear transformation. And in addition to that, we're going to use that property, and we're going to use some properties about bases. Okay, so we know that these three vectors, call them 1, 0, 0, 0, 1, 0, and 2, 1, negative 3, are a basis for R3. So what that means then, if you remember, is that 0, 0, 1 will equal, call it C1 times 1, 0, 0 plus C2 times 0, 1, 0 plus C3 times 2, 1, 3. 2, 1, negative 3. So what we're going to want to do is we're going to want to find C1, C2, and C3, and I'm going to show you why in just a moment. C1, C2, and C3. Well, if you remember, it's just basically transforming one vector in one basis to a vector in another basis. So we'll rewrite that. So that means that 0, 0, 1 will equal 1, 0, 0, 0, 1, 0, 2, 1, negative 3 times C1, C2, and C3. Okay. Now, all we really need to do in order to figure those three out is we can just go plug them into like StatCrunch, right? Find the A inverse. So this is, call this B, okay? Or, yeah, call this B, right? This is A, and this is X, right? So X is going to equal our A inverse B. It's just like utilizing that change of basis matrix, okay? And when we do that, what we'll end up with is X will be 2/3, 1/3, negative 1/3. So 2/3 times 1, 0, 0 plus 1/3 times 0, 1, 0 plus negative 1/3 times 2, 1, negative 3 will equal 0, 0, 1. Well, here's the question, like, why does this help us? Well, the reason why this helps us is that t of 2/3, 1, 0, 0, plus 1/3, 0, 1, 0, plus negative 1/3, 2, 1, negative 3 will equal, okay, t of 0, 0, 1, which is what we need. We need t of 0, 0, 0, 0, 1, okay? And so all I need to do is I now need to utilize my rules of transformation. So that means that this is going to be 2/3 t of 1, 0, 0 plus 1/3 t of 0, 0, 0, 1, 0 plus negative 1/3 t of 2, 1, negative 3, which will equal then 2/3 times 4, 5 plus 1/3 times negative 1, 1 plus negative 1/3, 7, negative 1. And you might ask yourself, well, where did you get those vectors from? What the hell? What's just happened? I get the whole linear transformation thing. Where did the vectors come from? Well, remember, that's how we define the transformation. They're from up here. They told us that the transformation t of 1, 0, 0 was 4, 5, t of 0, 1, 0 was negative 1, 1, and t of 2, 1, negative 1, 3 is 7, negative 1. So there they are. So there's our transformation, right? Hey, look at that. That's kind of cool. Okay. So what does that mean? Well, I'm going to kind of write them out. So that's going to give me 8/3 minus 1/3 minus 7/3. And then this is going to give me 10/3 plus 1/3 plus 1/3, which equals 0, 4. So t of 0, 0, 1 is equals 0, 4. And now I can construct my matrix of the transformation. So A is going to equal, well, t of 1, 0, 0 is 4, 5. 4, 5. T of 0, 1, 0 is negative 1, 1. And t of 0, 0, 1 is 0, 4. And there's our matrix of the transformation. All right, so you want to see something cool? Let's take 4, 5, negative 1, 1, 0, 4. And we'll multiply it by, well, 2, 1, negative 3. That's going to equal 8 minus 1. Okay. All right, because 8 minus 1. And then 10 plus 1 minus 12. Right, which will equal 7, negative 1. Just exactly what we thought we would get. Right? That's what we originally defined. So there you go. That's demonstrating that. That one's tricky. All right. It took me a little while to figure that one out. Hopefully this helps you to kind of illuminate if you're missing a standard basis vector, how can we put this all together in order to actually construct that standard basis vector? There's a couple homework problems like it. So I hope this helps.